Okay, we're talking about the transport layer, and instead of just going through the whole transport layer, I wanted to show you a little bit about the real operation of it. Um, but then you could read the materials about this. But the whole basis of the transport layer really is the idea of a socket. The socket is a combination of an IP address and a port number. Now, these port numbers are not the same as the physical interface on the router, and that's why when I talk about those things, I call them interfaces. I do not call them ports because ports are very specific in terms of the transport layer um, and what are possible. So every single service and every connection that's made, whether it's a service that's listening for connections or if it's a process on an NPC or device that's making a connection, has to have a port number associated with it. And that is so that the transport layer can receive all these packets that are destined for an IP address, and it can assign them to a particular process that's running in the computer. So I'm going to kind of show you a couple things. I have right here a version of Wireshark going, and all I'm doing is I'm capturing traffic on my local interface. So that way I don't have any spurious transmissions coming over. It's just capturing on local. And I'm going to use the utility called Netcat to basically open some ports. So I'm going to run this command as root. And this is the Netcat command, and I'm going to go ahead and tell it to listen. And I'm going to use the U switch because I want it to listen in the UDP mode. Okay. And I want to be very specific about that. And port. Now I could concatenate these switches, but okay. So UDP mode on port 32568. And then I want to do the same thing. I want to listen on port 32566. Now, the default listen mode in Netcat is TCP. So the U indicates UDP and no U indicate TCP. So what I should have, and I'm going to just look at the netstat command to look at ports that are listening on either TCP or UDP. Okay, perfect. That gives me 2 ports. Now, what will happen, I'm actually setting this up very specifically. When I send data over this connection, we're going to see some things happen in Wireshark. The first thing I'm going to do is I'm going to send a file that I have created. And this file, and I'll show it to you. It's right here. It's a little web page. Okay. HTML, header, title, body, and that's it. This is my page. All right. So I'm just going to go ahead and I'm going to send that document over my connection. And I'm actually going to pipe it. Okay, so I want to make it, I don't want to use a text redirector. I want to pipe this going from input to output. And I'm going to send it over to Netcat. Now, what I'm going to do first is I'm going to go ahead and send it over this UDP connection. Okay, we're going to make sure we use port 32568. But I have to do I'm going to send it to the host, because I can do this over any host on the internet, but in this case, I just happen to be running the other sides. So 32568. That's a UDP port. Now, notice what happened. It refused my connection. What happened here? I made a send request and I got a reset back. The issue is that when I made the request, I actually didn't make it in the UDP form. So if I'm going to use the UDP to communicate, I have to tell my Netcat. But this is a perfect example of what happens when we communicate using the TCP connection that on a service that is not TCP. Is it says, no way, that's not going to work. Not going to do it. I'm going to send you a reset. Okay, so now we're going to go ahead and do it the real way over UDP. So here's our connection, UDP. It's listening. I'm going to clear it. That's going to terminate the connection. But because the UDP doesn't actually send packets that terminate connections, we never know. But here's our packet. Here's our UDP packet. And as you can see, this has the web page in it. All right. Okay. And just to confirm, I'm going to go ahead and run netstat LTU. And now I just have one connection running, a TCP connection on 32566. Now, a couple things are going to happen here. I'm about to run the same thing. I'm going to go ahead and I'm not going to try to send it over UDP, although I could. We can see what happens on that. If I try to send this file over UDP, now I'm actually initiating the connection via UDP. There's a stateless connection, so I'm just going to create a packet, and boom, there it goes. So we're going to see what happens. What happened? Oh, look, an ICMP packet. Destination unreachable. So that's great. So we initiated that request, and the server said, destination unreachable because that port is unreachable on UDP. Okay. All right. So that's what happened there. Is I sent this request. This went out, and boom! Immediately, I got a response. Not happening. Okay. Now, what we can do is we'll just double check. We'll do a netstat. We're going to look for listening connections that are both TCP and UDP. And look, we still have a TCP connection open. It was never a successful connection, so there's nothing to close. So I'm going to go ahead and send my file over this connection, but I'm going to send it like it's supposed to over TCP, not UDP. The port number is 32566. They should match. Okay, now before I close the connection, I want to go back over here to Wireshark, and we're just going to look at this. So you see how the TCP connection made a lot more stuff going on. There's a lot more control here. So here's our TCP connection. We did a send request. It said, hey, I need to establish a connection with you. The server said, okay, I'm going to acknowledge you that I got your request. Then my other side said, okay, I got it. The next thing that happens is a push packet with an acknowledgement. Boom, here's our data. Now, if I had a larger document, I would use more than one packet to fill this up. It would begin to fragment the packet, and it would send them all. And then I have an acknowledgement that I received it. Okay, that's comes from the other side. Now, notice that I still have the connection open over here. I haven't closed it yet. It's still waiting. But when I do that, when I do Control C and I close my connection, we're going to see the other part of this happen. Boom. Now the connection's closed. And here's our finish from the initial, our finish from this other side, from the remote side, and then the acknowledgement. So these, as you can see, there's a lot more overhead. There's a lot more overhead in this document. If we were to look at how much that let's just add up the file sizes. And have one more 66. $561 bytes versus my initial, which was 191. Right. So on bigger files, obviously the overhead's worth it, but on smaller documents, I'm almost 3 times as big. So for little requests, and especially with lots of small images, lots of little bitty things that are very tiny, this can totally fragment the internet. And so there's a push to combine and compress and do lots of other things with the datagrams that are sent over the network to make this process more efficient. But what you should see here is that we looked at both. Now let's just analyze these packets a little bit. First of all, we have our TCP packet. It was a SYN request, and we see a couple things here in this header. Okay, we have the source and destination port. This is the very first 2 things that are in there. That's 2 bytes, 4 bytes, 2 and 2. These things are calculated. We have a sequence number of 0. That means that this is the beginning. And then we move on down to the next packet, which is that reset packet. Now this is the same port. Notice that the port that we're sending and receiving from, this is a randomized port, 46498. Now I could have picked that when I created the connection, but this is the randomized port, and this is this actual packet sequence number that comes over. And so that's the reset. We don't have anything else. Now this is the UDP packet. We're going to look at it. It's very similar. It has a source and destination port. It has a length. It has a checksum. And that's about it. It doesn't have any other information inside of it that helps us control it, that helps us know what comes next. There's nothing else in there that's going to tell us any information. It's just data. There's a lot less in there, right? Hey, here you go. Boom. Hope you get it. But we have a lot of stuff here. We have the sequence number. We have acknowledgement, which acknowledgement it's expecting. We have flags. We have window size. We have lots of information that we can use to begin to set up a transfer that are just not there. Here's options. So we have maximum segment size. We have selective acknowledgement. We have window scaling. We are setting up all these different settings that I can use to transfer large amounts of information completely reliably. And our UDP packet just has data. Okay. So the same thing with the establishment. We're really working hard here to establish communications in TCP. Now, a couple things here. First of all, this particular port number, this is my source port. This is my destination, 32568. So it's source 48498. I made that. That was random when I initiated the connection. Notice that the source port here is different, 42740. It's a completely different source port number. The operating system created that when it initiated the request and built the packet. But the ports are actually, let's see, in this case, I was sending the wrong type of request to the other port. So that's why the port numbers are different. But now I'm sending the right request to the right port, and you can see that the port number is different here. But each time I have a back and forth connection, I have the port numbers on the destination and source are swapped. So you can see which one was originating and which one was not. So right here, we have this initiating request, source destination. Then we have the response, source and destination. Then we have the next response, source and destination, and then we go ahead and send data. So can we make a connection? Yes, I heard you. Did you hear me? This one says, yes, I heard you. Here comes the data. Bam. All right, here's the data. Now, this particular packet has a sequence number of 1. And if I had to send more, right, I could do that. It's ready. This sequence number here, next sequence 150. I could send some data, right? Because my actual data is 149 bytes. So if I had more than that, this is what Wireshark calculates, that if I had another packet, I should expect that the next one's going to be 150th byte right here. Right? That's what that means. It's telling me, okay, you got 149 bytes of data, next one's 150. It obviously didn't use that because, but if we would have had a bigger file, it would have done that. And then we have the teardown process here. But I wanted to show you that and it's really get you the opportunity to see that in action. And you see that teardown process, you see that establishment process, you see the ICMP unreachable process that happened. You see the UDP packets that were created when I sent it over UDP. You see the size that's small and the size that's big versus the UDP and TCP. And then we have that initial TCP connection that was sent to the wrong device with a reset flag. Boom. Bad. Now, notice the interesting thing about this is that when that reset flag hit, because I hadn't actually received the service I was expecting, that service stayed open. It kept listening for a UDP connection. It just sent the TCP packet to deny the request. All right.